All righty, Jeff and Matt, you're good to go.
Great, thank you so much, Anka. Welcome, everyone. Just a few other quick words if you're wondering why two folks from Detroit are doing a presentation on the Smarter DC Challenge. Ultimately, Matt and myself are part of our lighting design studio here in our Detroit office of SmithGroupJJR, and our studio is the national resource for the firm from a lighting design standpoint. So we get involved in projects that are within the company across all of our offices, including our Washington, D.C. office. And we do work with outside architects and owners directly as well. So that's the reason why we're on board today. But we wanted to get going really kind of talking about lighting strategies, how to leverage technology and design approaches. And Anka, why don't you go ahead and move to the next slide here. So when it comes to lighting, Matt and I could talk quite extensively about lighting in many different. Today we're really going to focus through the lens of sustainable design. And just as with the Smarter DC Challenge, the different strategies that exist within the challenge of energy and water and transportation and waste, when it comes to talking about lighting, there are always factors that need to be balanced when you're looking at sustainable design relative to lighting. And so things like risks and the costs involved, technology and performance, those are all issues that we need to balance as we go through the design process and look at how to apply this within different applications. When it comes to lighting, obviously in sustainability, the first thing that likely comes to mind for most people is energy, right? And we think that through lighting, if we save energy, we can save energy costs, and that's a great thing from a sustainability standpoint. And we're going to talk about those today. But I also want to make sure that we don't lose focus on the other impacts of lighting that impact what I believe a truly sustainable design for a project is. And so we have to think about other costs as well. It's not just energy costs, but thinking about long-term maintenance and the costs associated with that. We should be thinking about staff costs. And this is where the element of lighting from a design standpoint and realizing that lighting truly shapes our perception of an environment and provides not only the right quantities of light for a certain task, but also shapes the way we see space and the way we experience space, ultimately impacts occupant comfort and their satisfaction with the environment that they work in. And when you make that kind of connection to lighting, you realize there ultimately can be productivity impacts as well to your staff. Taking a look at those costs, that can be a significant portion of your actual cost, well beyond those of energy efficiency, but ultimately relate to the sustainability story. So I hope you hear that thread interwoven through our presentation today on the different topics that we're going to cover. Next slide. So really the starting point with any lighting that you're looking to do, whether it be a renovation or a retrofit of an existing space or even a new building, the basic starting point as it relates to lighting and sustainability is how much light do we really need? Because ultimately, again, there's the direct correlation between how much light we provide in the space and how much energy we're going to use. So obviously, if we can limit the amount of light that we need in a space, we've therefore saved energy and created a more sustainable project. The important starting point for any project, again, whether it even be a retrofit, is to make sure that whoever's looking at your space and establishing what those target design levels are from a lighting standpoint, that they're referencing the right standard and that they're using the IES handbook, which is really the ultimate authority from a lighting design standpoint. Oftentimes we find clients, within corporate sector, a lot within the university markets, that may have their own established standards, and most times they're quite outdated. They may have been created based on someone's personal preference. They may have been based on facility manager's preference, or even older standards of the IES. But the IES continues to evolve in terms of recommendations, and there's a lot of research that's ongoing in the lighting community in terms of impacts of light, not only from a visual standpoint and what we need for tasks, but also things even like the biological impact of light on humans. And so as the IES gathers more of this research and understands more and more about it, they alter recommendations to be as appropriate as the research can keep us up to date. So even if you're using an IES handbook that may be 10, 15, 20 years old, you will see the illuminance levels, the target lighting levels in those earlier standards are higher than what today's standards are in many cases. So it's important to realize we want to be, first of all, designing around the current recommendations. But we also need to take a look at within a certain building type, you really have to make sure that you're designing around the predominant task and not the worst case scenario. I want to use just kind of an extreme example that's outside of the office environment, but that I think just kind of paints the picture for us. If you think about a hospital facility and the amount of light needed for a surgeon to perform surgery on someone in the operating room is an intense amount of light that's required. On the flip side, you may have the amount of lighting that's required for a nurse, say, to fill out the patient forms and to go through their charts. Two radically different lighting needs, and we clearly don't design the whole hospital to the surgeon's need that he needs in the operating room. We do it based on the predominant task that happens throughout the facility, and the same thing happens within an ops environment. So you really need to understand exactly what kind of tasks are being done, whether they're more computer-driven, whether they're paper-intensive. Even size of font comes into play in some of this. So making sure that you're really dialed into the actual tasks that are going to be performed in those spaces is absolutely critical. And then ultimately as well, we want to take a look at the ability to fine-tune the lighting that we design into a building. And kind of the obvious examples that we immediately would think of would be conference rooms and areas where you have multi-function type of space that could range anywhere from doing an AV projection and having to project onto onto a projection screen where you want very low light levels so you're not washing out the screen, to just having a casual meeting conversation, to a scenario where you might be really digging intensely into documentation and it's a lot of focus on paper and that type of thing in small font and small print. Those each require a different amount of light, and you want the ability to fine-tune those. That's kind of the obvious example, and I think we all have examples of the ability to dim or set theme controls within spaces. But there's another way that, that fine-tuning lighting could really have an impact through load shedding as it relates to really lowering the lighting, the overall ambient lighting levels within a space to allow you to save energy and shave off some of those peak energy demands throughout the course of the year. It could be something that's tailored to certain times of the year so that when you have your highest overall mechanical loads in a space that you shave the lighting back some. It can be handled in a number of different ways, and I know that Amanda will probably pick up on some of this during her portion of the presentation, but it's just kind of something important to keep out in front of us as we think about how much light we really need. Next slide. So after we've had the ability and we've set the target of what the goal is, one of the next decisions, and this might seem pretty basic, but it's the lighting approach. I mean, it's how do we deliver light to the space, and how do we provide the right kind of light for those tasks? We're going to talk about three kind of major lighting approaches and the pros and cons of each of those in terms of delivery of light. We're going to talk about recessed direct lighting, a pendant direct indirect approach, and a task ambient approach, and ultimately we want to really understand their sustainability implications, both from an energy consumption standpoint, from an occupant comfort standpoint, and also from a cost perspective. Next slide. So when we talk about recessed direct lighting, this is really kind of the most basic level, if you will. From an efficiency standpoint, it is the most efficient way to deliver light from a ceiling plane to a horizontal work surface. You're seeing an example of a picture here from a project that we did with Google, and in this scenario, actually the space was existing, the lighting in the ceiling plane in terms of the 2x4 lighting was already existing, and we came in and did the interior lighting schemes and furniture layouts and that type of thing within this project. So there was already a fixed kind of shell, if you will, around the space. This is a low-cost alternative. It's typically the lowest cost alternative from a lighting fixture standpoint. From a visual comfort perspective, it's good. It's not great. It's good. The example in this image here is better than what you may see in a lot of older spaces throughout the country. That was the common design approach used in the 80s, 90s, and early 2000s, which was to use parabolic recessed fixtures in a ceiling. They were extremely efficient in delivering light to the work plane, the horizontal work plane, but the side consequence of that is that you don't get as much light on the vertical planes, on the side walls, and certainly no light on the ceiling plane. So you start creating kind of a darker overhead scenario and can create a sort of cave-like feel depending on the fixture design that you utilize in that direct approach. From a flexibility standpoint, ultimately what you're doing in this kind of approach is you're providing uniform lighting across the entire space. It doesn't matter if it's where you're actually sitting and doing paper tasks at your desk, or if it's where your seat is, or if it happens to be kind of a walking space within the workstations. It's all illuminated to the same level. So it's very uniform. It provides some flexibility in terms of seating arrangements, but really may not be the most efficient overall in terms of an overall design strategy. Next slide. So the next step up from there is a pendant direct-indirect approach. This improves upon the last scheme in a number of respects, most certainly in terms of visual comfort, which really rises to what we would consider an excellent level in this kind of condition. It's the perfect balance of direct lighting component from the underside of the fixture that you can see glowing in this image here, and also relying on bounced light from the fixture that's bouncing up on the ceiling plane and back down to the work surface. So it provides a high level of visual comfort, which is outstanding. But with that comes a little bit of a cost in terms of efficiency within the delivery of the light, again, to a horizontal work surface within that space. It's a bit less efficient because you're directing some light up onto a ceiling plane, or in this case, into an open ceiling cavity, and you're going to lose some light in that process. So you lose some of the light, and therefore some of the energy that's being invested in that light is being lost to create this type of lighting environment. That being said, ultimately, it's overall a better visual solution, as we said, from the standpoint of visual comfort and minimizing glare within the space. It also provides a higher level of ability to interact with daylight and daylight dimming, because it begins to mimic the way daylight reads within the space, which is to light the ceiling plane and kind of fill more of the volume with light. So you can now kind of integrate the dimming aspect of lighting better in a pendant direct-indirect type of system than you can with a direct recessed direct system. From a flexibility standpoint, again, this is very similar to the direct recessed direct approach in the sense that it provides a uniform blanket of light across the whole space, and therefore allows flexibility of positioning of workstations within if you're a tenant. But again, it provides kind of a uniform level regardless of what the task is in that area, whether it happen to be a circulation zone or whether it be where you're working on a paper task. Next slide, please. And then finally, this is kind of the highest level, I guess, if you will, and really, from our perspective, the best level from a sustainability standpoint in terms of a lighting approach. A task ambient lighting solution is really a two-layered lighting approach to providing light for working tasks. You're providing a base layer of ambient light. It can be either through a direct system in the ceiling or an indirect system, but most often we see it paired with an indirect lighting scenario. But then you're pairing that with having task lighting that happens specifically where it's needed, and most typically, as you see here in this image, that task lighting happens at the actual workstation for each individual. The benefit of this approach is it allows you to lower the ambient lighting level within the space. And in doing so, obviously, you're going to achieve energy savings in doing that. So you provide an overall much lower lighting level through the entire area, working area, realizing that tasks on a computer don't require light because you have a self-luminous display. You've now minimized the amount of energy that's required to provide that ambient layer of light within the working space. Then you're really relying on the task lighting to be something that people can turn on and off as needed if they're working on certain paper tasks that may require a higher ambient light level. What you often find in a task ambient solution is that the task lighting doesn't get used a whole lot of the time, which is a great thing as well, because then it minimizes the energy consumption through it, and staff that may desire a higher level have the ability to achieve that for themselves with that task light. The thing that really kind of positions this well, I believe, into the future of the workplace environment is when we think about increasingly mobile workforces and the ability to work from home more often, or just not to be in the office working in different conditions depending on your industry. You're now not taking an energy penalty, in a sense, of lighting that entire space at a higher level when someone may not even be at their workstation. So this is really a great approach as work environments begin to change in terms of our approach to staff and where they work. This provides some real flexibility for the future and is a great opportunity for a tenant to be able to control that for themselves within an environment. It's also a great thing if you happen to be a tenant and you're not filling up the entire space that you're renting, then you're not lighting the entire space at that higher level of lighting. You're providing that lower level ambient throughout and just using the task lighting to pick up where you need it. So the big thing here is that energy savings, but it's also user control, and having the enhanced user control of the ability to control your own environment really begins speaking more along the lines of what I think a sustainable environment truly is, which is a healthy environment where people feel that they have the ability to control their own environment, where they're sitting and where they are. And certainly a task ambient approach is a great way to do that. Next slide, please. So now we're going to switch, and we've talked about how we're providing that light in terms of an approach into the space. Now we're going to dive a little deeper into that fixture and into the light source that's creating that light. And this is really where our industry has seen a lot of technological and continues to see a lot of technological advance. And so, and this is likely more often, these are the buzzwords, these are the things you hear about as they're coming out, and it's what manufacturers tout, and for good reason. So we're going to talk about some of 3 predominant light sources that we're going to go through and discuss their advantages and uses. And those 3 predominant sources are an LED system, a retrofit LED, so in which scenario you have kind of a self-contained LED source that could be placed into an existing fixture designed for another type of source, typically a fluorescent, and then comparing that as well to the fluorescent source itself. Next slide, please. So the sustainable progress that we've been able to make with these sources, just to highlight overall, the image on the left that you're seeing, these are both graphics that were prepared by the Department of Energy. The Department of Energy is heavily vested in this development of sources, predominantly because they see the major impact that it can have on our nation's energy consumption. And so what we're looking at in the graphic on the left is a lot of different aspects of sustainability that they're looking at and trying to measure. And the different rings that you're seeing, the red, the green, and then the smallest, the purple, are looking at the different sources, going from a compact fluorescent to a first generation LED, which is entitled here LED 2012, and then a current day, which is LED 2017 that they're calling, in that tighter ring. And what you're really seeing is that overall we're moving towards more sustainable sources in almost every measurable category, which is a good thing. The other thing that we're seeing and that we can expect to continue to see is you're seeing here a chart that's charting efficacy today and into the future. And why that's important is the other sources that we have currently at our disposal are mature sources, meaning that they've reached their pinnacle of efficiency. The place that we're at with LED, it is not yet plateaued. And so we expect to continue to see, as you can see here, out through 2025, looking at continuing to increase that efficacy, so the amount of light we're getting per amount of electricity we're putting in, we're going to see that continue to increase to higher and higher levels. Next slide, please. So when we think about the light sources, the predominant piece that comes up in terms of sustainability is efficacy, because it's the direct result of placing light into a space at what energy cost. So efficacy is saying, how much light am I going to get for that 1 watt that I'm putting in? And so in looking at that, on the graphic on the left, you're seeing a comparison of different sources, ranging from incandescent or halogen all the way up through LED. And what you're seeing as well is there's these colored bands. And one thing to remember is that the efficiency of a source is only ever as good as the fixture that it's placed into. The source is going to have a range of efficiency depending on the efficiency of the fixture in which it's placed. And so what you're seeing here with that colored band is there's a range. Depending on what fixture you place the linear fluorescent into, that range in efficiency could go anywhere from 40 lumens per watt all the way up to around 100 lumens per watt, which is a fairly wide range. So it's important to look at. But you'll also notice that on those sources, all the sources aside from LED, there is that hard line cap. And that is showing that that is a mature light source
as we kind of call it in the industry, and that means that we don't expect to see efficiency gains in the future. We've reached pretty much the theoretical maximum of how much light that process can output for the amount of energy being put in. What you see, LED at the bottom, is that cap has not yet been reached. That bar is going to continue to move into the higher efficacy range as the LED technology continues to increase. Now the graphic on the right starts to speak to some of the differences between what we're calling here an integrated LED lamp, which is your retrofit type, and your LED-based luminaire. And so what we're charting here is the amount of output and also the efficacy. And what you'll notice from the scatter plot is that there's really kind of a maximum output that you can get out of a retrofit or an integrated LED light source. And the reason being is LED is very dependent on heat. Heat is the enemy of the LED, which I'm sure a lot of you have heard about. When we're looking at integrated lamps, we're combining a lot of different things into a very small package, which means that all those different components are in close proximity. There's not a lot of material for heat sinking, and we're putting it into a fixture that wasn't necessarily designed with cooling in mind. And so for those reasons, we have a maximum in terms of how much light we can get out effectively from those integrated or retrofit LED sources. The LED luminaires, on the other hand, now you're seeing that we can get more light out of these and still remain very efficacious in doing so, because these fixtures and the components have been designed in a manner to mitigate that heat and to allow for that higher output without the detriment that the heat would cause otherwise in an integrated source. Next slide. So now let's talk more specifically about LED. LED, when we look at this, one thing that we want to talk about is that it's not just the LED chip that we should be thinking about, especially in terms of life, when we're talking about life, because life is one of the great aspects of LED, specifically for the chip. However, we need to look at, this pie chart is showing the amount of, the percentage of failure. So the first piece of the system to fail. And what you're seeing here is that only 10% of the time, a small sliver of the time, is the LED chip the failure point. The other 90% are the other components that go into that light fixture that are the first point of failure and are the weak link in terms of a maintenance or hours. And so the thing to think about, especially in looking at that large driver quadrant or power source, is if that is going to be the first point of failure, let's make sure that's easily replaceable. Let's make sure that's easier to access. And that way we're able to realize that extremely long life that is able to happen from the base LED chip. In terms of efficacy, as you're seeing here, we're showing 120 lumens per watt right now. That's kind of a today level. And we're showing that plus on there, understanding that as the technology continues to mature, that number is only going to go up, approaching that kind of theoretical limit of somewhere in the neighborhood of 250 lumens per watt. Also, the thing to note is it's a directional delivery. And what I mean by that is the light that's coming off of that chip is only going in one direction. It's not shooting any light backwards. And that's something that we'll take note of as we look at the comparison sources, specifically fluorescent, understanding that that source is omnidirectional. It's shooting light in all directions. So a lot of times we're able to realize a better overall efficiency of our lamp and fixture combination because that LED natively is shooting all of its light in one direction. The other piece to talk about, we've touched on the hours and the life of this thing. Again, it's right currently, this is another one of those numbers that seems to continue to expand. And really the reason that that's happening is as our efficacy improves, we don't have to drive those LEDs as hard. They're producing more light with less wattage, less heat. And so we're able to realize longer and longer lives because we're not driving these LEDs as hard. So currently we're seeing in the industry up to around 100,000 hours, which is really an extensive lifetime for a light source. As we look at the material properties, one of the benefits that we see in an LED is mercury-free. The fluorescent lamping that we've had for a long time contains mercury, which is not only difficult to handle when we dispose of the lamps, but also poses risks if there is lamp breakage. How to appropriately clean up that area. We've had university clients that have absolutely jumped at the ability to move away from fluorescent simply because the cost that they were having to incur every time a fluorescent lamp was broken to have a hazmat team come in and deal with the mercury that was in the space was astronomical. So it's a big piece of the sustainability puzzle when we look at LED. Also, control, as we're going to talk about more in terms of all the different ways we should be looking at control to save energy, LED really lends itself well to control because the LED is inherently dimming. It's inherently able to be dimmed. And when we dim it, it dims very nicely and it remains consistent color temperature. The lighting properties that are coming out of that LED don't degrade as we dim it. And so that it really lends itself well to a lot of the load shedding and dimming strategies that we'll talk about. The cost, the cost again is one of those things that since it is not yet a mature technology, it's something that we've seen fluctuate, but we've seen it steadily decrease. It is still more expensive than a non-dimming fluorescent scenario, but we're not seeing it as a large adder at this point. It's very much on par if you were to try to balance it against a dimmable fluorescent system. Next slide. So the LED retrofit lamp. So this is the one that it's a package deal. Everything's kind of in this one tube or whatever the form factor is. And the idea is that you're able to buy this one lamp, and then with the fixtures that are in your existing space, you can plug this lamp in, and now you've transformed your fluorescent or your incandescent fixture from that into an LED fixture. There's some, again, you're seeing here a fairly high efficacy, and it still has that directional delivery because it's still that there's an LED inside of this thing. You're seeing a hit on the life. And really that comes down to what we had discussed a bit before, even in terms of efficacy, but that the life is going to be a bit less, and that's predominantly due to heat. And that's because we're combining a lot of electronics in a little tube. We're not able to spread those things out and dissipate their heat as effectively as we can with a native LED fixture. So that heat is causing the LEDs to degrade more quickly than they would in an LED native fixture. So you still are realizing the material property, the benefits of not having mercury, and the control here is a bit more difficult. It's a bit more difficult to look at and to understand because a lot depends on what fixture you're going into, what existing controls you might have, and what that retrofit fixture or retrofit lamp is able to do in terms of control. You likely will still be able to realize some dimmability. It typically won't be as wide a range as you can on a native LED fixture. And so that's one thing to look out for and to test and to make sure you understand if you're looking at an LED retrofit solution. The cost, this is the reason that this is looked at, is you don't have to necessarily replace your base fixture. You're not buying an entire fixture. You're simply buying the lamp. So it's less costly than that complete fixture replacement for this type of an application. So the first costs are a bit reduced over a native LED. Next slide, please. And then the final is our fluorescent lamp, which a lot of folks will tell you is gone and should never be used. We're not quite there yet. The fluorescent tube can still be a good light source in certain applications. It can be incredibly cost effective depending on what you're doing with it. So you can see efficacy is still fairly good. We're at 100. It's not quite as high as the best LEDs right now, but it's still a very good efficacy. It's omnidirectional, which in certain circumstances, as I mentioned, can hurt the efficiency of the overall fixture in delivering the light. But in other scenarios where you want that light to be spread in a very broad pattern, it can be beneficial. The life, again, it has a fairly wide range. They've been able and have the biggest technology advances recently with fluorescent is in life. They've been able to make some of the high-end LED, or not LED, fluorescent lamps last up to 70,000 hours, which is really more than doubling the previous and the standard life for a fluorescent lamp. So that's where you're seeing most are in that 30,000 hour range. There are some more specialized high life lamps that can realize up to 70,000 hours. The material properties, again here, this is where you will have some mercury. You can get low mercury content fluorescent lamps, so they're reducing the amount, but it always is going to have some mercury in there. The control, again here, it's not inherently natively dimmable. So we need to add a dimming driver if we want to try to dim a fluorescent lamp. And then even when we do that, at an additional cost, there are other side effects we have to be aware of, that at very low levels we may very well see flicker. That as we dim a fluorescent lamp, the lighting on the lower end will purple or blue. It'll change color. And it's just because of how we're delivering light through the fluorescent tube, and when it dims, it doesn't maintain that consistent light output like an LED does. It changes. But the cost, and again, this is where this lamp can still be useful and efficient, is if you're not looking at a dimming application, and if you're looking at an application where a broad spectrum of omnidirectional light is beneficial, this can be a very cost-effective means of delivering light at a pretty good efficacy. Next slide.
Okay, now we're going to move into the daylighting aspect and how it can have implications in sustainability and lighting design for spaces. Obviously, the opportunity with daylight is make use of daylight and minimize your electric lighting usage, right? That's kind of the obvious thing. We talk about dimming strategies and ways to accomplish that. Again, Amanda will talk a bit more about how you can do that through control systems. What we wanted to focus on was some approaches. Again, if you are a tenant within an existing space and you don't have the ability to redesign a brand new building, or you're not reskinning a building and you kind of have what you have in terms of windows, how do we make use of that? What's the best approach here? So we're going to focus in on maximizing daylight penetration into the space and minimizing the usage of shades. Next slide. So daylighting can be a really technical conversation, and we do a lot of really sophisticated and advanced daylighting calculations and studies on projects. But again, we're going to talk a bit more about how, if you're in an application where you're looking at retrofit or an existing shell, how to navigate some of that. Obviously, if you're in a condition with brand new construction, you want to look at things like ribbon window conditions versus punched windows. You want the windows to go as high to the ceiling as possible, which will maximize daylight penetration deeper into the space. But again, assuming that we don't all have the ability to do the new building design, what do we do in existing spaces when we're looking to move into a leased space and understand how our program may fit into that area? I think there's a couple of strategies that come to mind, and the first and foremost is the moving private offices or enclosed spaces from the perimeter of the building to the inner core. And in so doing, you then open up the perimeter areas for open office spaces that then can allow daylight access to the majority of the staff within the space. So really it becomes a programming discussion of how you're going to program, how you're going to utilize your floor plate within your building. It doesn't mean that the inner offices towards the inner core aren't going to receive daylight or have views. You can still have glazed partitions or look at different approaches that allow those offices to have views out through the exterior windows, or to have some daylight penetrate in as well. But you're really kind of providing a broader base for the larger population if you pull those offices to the inside versus the perimeter of the building. The second that you'll see here on the left-hand image on the slide from a recent headquarters that we've designed is the use of low partition heights, making sure that those are low enough that allows the daylight to actually penetrate into the space. You know, it's really easy to do some daylighting calculations and just do it with an open shell and just an empty volume, which is the way most daylighting calculations are done. But that really won't be the reality if you move in with 4 or 5 foot high partition heights up towards the glass, where clearly in that kind of condition you're only going to get daylight penetration to that first group of workstations. The second example is where you're in a condition where maybe you really can't eliminate those perimeter offices or those perimeter enclosed spaces. What do you do then? The second image on the slide there is a space that we designed at Penn, where there were going to be perimeter offices utilized for professors. And in this kind of condition, you can see our strategy to allow daylight to permeate from the exterior offices into the inner corridor and inner spaces was to introduce a clear story condition that happened on the inner partition above the doors. So running the entire length of this inner space is a clear glass clear story that still provides the acoustic privacy for that office, but allows daylight that's bouncing off of the ceiling plane within the office to also reach into the inner core space of the building. It really then allows us to minimize our energy consumption in those inner core areas during the day, even though there are perimeter offices. The other approach on that project that you can see in the foreground is the use of translucent glass for some of the wall area, so that again you allow a visual privacy to still be achieved for those offices, but you still allow the daylight to penetrate and transmit through into the interior. Next slide, please. And then the second portion here, in terms of talking about minimizing pulling of shades, you know, this sounds kind of silly, but it's actually it's an important issue that actually the industry has done a lot of research into to understand how much daylight we actually lose because shades are pulled because there is problematic glare from sun penetration. And I think that the important distinction here is the difference between sunlight penetration into a work area and daylight. We want to, as much as possible, exclude sunlight, which brings along with it the solar heat gains that come with it, and rely on daylight, which is really the diffuse quality of light that comes from the sky dome, from the atmosphere, and from cloud cover. That diffuse lighting condition is actually the perfect quality of light that you want in a working environment. So the image on the left, you can kind of get a sense of what that diffuse quality is that you normally have on even a cloudy day. So even in areas of the country where you may not have a whole lot of sun per se, can be great areas to achieve great daylighting within working spaces. You'll see a lot of fantastic daylighting designs done in the Pacific Northwest and in Europe, in areas where you have a lot of heavy overcast cloud coverage, because it provides a great opportunity to provide diffuse quality of light into the space. So if you don't have the ability to do exterior shade and louver design, you want to be considering other approaches to handle the interior. The image on the right is actually a project that we did outside of the Phoenix area, and you can actually see at those windows there are horizontal louvers that we went through a sophisticated design and optimization process to minimize the portion of the year where you would have direct sunlight penetration into the work environment, but would still maintain maximum views out of those windows and maximum useful daylight in the work environment. So things like glazing specification come into play when you're looking at an opportunity of designing a new building. In the case where, again, you're coming into an existing space, how do you achieve some solutions when you may not have the ability to control through exterior shades or louvers that sunlight penetration? Well, one option is, again, through kind of the planning and programming of the space of creating a perimeter deadband. Again, the example in the left-hand image where you pull the workstations away from the perimeter wall and allow those to be more transition zones, where if sunlight penetrates, it's fine and that it's in the transition zone, but it's not coming across your desk, creating a problematic contrast condition. The other thing to consider is your workstation locations and layouts. Again, pulling those first workstations back from the exterior wall slightly if you can't protect it from direct sun will allow you to minimize having to pull shades in the middle of the day and having those impact the daylight available for workstations. It'll allow those shades to be up, and it doesn't matter if the sunlight hits the floor. That's a great thing. You just don't want it hitting your desk surface. One last consideration is the orientation of your workstation relative to the exterior wall. and you can see it in these images, but certainly on the left-hand image where the monitors are more visible, the monitor positioning is perpendicular to the exterior wall plane. That's going to create a condition where it minimizes the potential for glare from daylight, from the brightness of the window, and from the sun on the computer screen. So as you're looking at the way you may be able to lay out spaces within your leased space, look at those monitor orientations being perpendicular to the exterior wall. I think that wraps up our daylighting piece here now. It's really time to turn it over to Amanda and let her talk through lighting controls.
Sounds good. Thanks, Jeff and Matt. So hello, everyone. My name is Amanda McLean, and as Patty said, I work for OneSource Associates here in DC. OneSource is the local Lutron lighting agent, lighting controls agent, and I work with local designers and engineers, such as Smith Group, to design lighting control systems for their buildings. I actually previously worked up at Lutron for 7 years before transitioning down to sales here. So we're going to dive into some lighting control strategies that you guys could deploy for your different projects. Next slide, please. So let's look at the lighting control opportunity that you guys have. This really plays into what Jeff and Matt were both talking about in terms of buildings today often being overlit. Perhaps that's because they were being lit to the worst case scenario, to old corporate standards, or to even the last bullet point here, that they were built before 1989 when lighting levels were just higher. So a lot of spaces today are overlit, and we could afford to take that lighting level down. A lot of spaces today don't take into account daylight. And that's not talking about the building itself, right? A lot of designs today are bringing that daylight into the space, again, just like Jeff and Matt were saying. But we're talking about the lighting controls here. And oftentimes, the opportunity for controls is to be able to dim or reduce the electric light in the space based on that diffuse daylight that's coming in. So that's what we really want to take advantage of, is using those windows as another light source, as another light fixture, and being able to dim the existing lighting. A lot of lights are left on in vacant spaces, right, or after operating hours. So how do we get those lights off so that we can save that energy? Another opportunity. And that last bullet point is about 75% of buildings were built before 1989. And 1989 was when the first lighting control standards came into play. And that's what we're going to go through, is some of the lighting control strategies that are deployed in buildings today. But before that time, there really was nothing other than potentially a toggle switch on the wall, if that. A lot of spaces just were lit 24/7. So there are a lot of opportunities to save that energy from your lighting. And simply, the only ways that you can save energy are to turn the lights off or to dim the lights. That's it. Right? It seems to oversimplify it, but really when we're talking about your electric lighting, that's how you're going to save the lighting energy. Let's go to the next slide. So I do understand that I've oversimplified it by stating that you're just turning the lights off or dimming them, because while that is true, it's really the strategies that we're going to go through that allow us to do that while still maintaining or hopefully improving productivity for the occupants. And that's really the key, is that we're turning off or dimming the lights only when it's really required, necessary, or beneficial. So let's go through some of these strategies. So the first lighting control strategy to exist was called scheduling, and that's really just an attempt to turn the lights off when the building is unoccupied, typically at night. Right? Scheduling is when you've got a time clock style device that turns all of your corridor and potentially open office lights on at 7 a.m. and turns them all off again at 7 p.m. So that was the first strategy to be introduced. And again, that was really just the first attempt to get lights off when people weren't in the space. That was a great first step, but what transitioned out of that was that there are a lot of spaces left unoccupied during the day, during working hours. And how do we save that energy? So occupancy sensors came onto the scene. So occupancy sensors have been around for a long time. I think there's a lot of people out there with a sour taste for occupancy sensors because there were a lot of hiccups when they first came out. But that's really a technology that's improved and stabilized. So if you are hesitant, I would encourage you to get back into that type of sensing. And it's important to understand the two types of sensing that are out there, occupancy and vacancy. Those are very different. So occupancy sensors are what you would use in an open office scenario where you walk into the space, the lights automatically come on, you go about your task, and then when you leave the space, the lights are going to turn off from that sensor. So you don't have to think about turning the lights off. It's great for a situation like an open office. Vacancy sensing, however, is becoming more and more required by code, and including in our area in DC, Maryland, and Virginia. And vacancy sensing is where you're going to walk into a space and nothing's going to happen. Your lights are not going to turn on because it's forcing you to make the decision, do I need light in this space? If so, I'm going to go over and turn the lights on myself. Then when you leave the space, that sensor is going to automatically turn off the lights behind you. So that's actually going to save you more energy than occupancy sensing because it's forcing you to make that decision to turn the lights on in the first place. It's a great strategy for a space like a private office. Perhaps you're just walking into your office to grab the business cards that you forgot, and then you're leaving again. An occupancy sensor is going to turn on those lights unnecessarily. So you're going to see a lot more vacancy sensing. One thing to note about that, though, is that those sensors often look the same on the ceiling. So it's something that you need to get your occupants aware of, because it's sometimes confusing that lights are automatically turning on in some spaces and not automatically turning on in others. And they may think that that's a faulty product, right? They might start waving their arms about like they have in the past to get the sensor to see them, and that's not going to happen because it's intentional. Next slide, please. So occupancy and vacancy sensing, I mentioned that vacancy is going to save you more energy. There was actually a study done that there's kind of an intermediate strategy that saves the most energy. And that's actually having your lights turn on to a preset level. So having the sensor automatically turn your lights on to, let's say, 50%. You would still have to provide an override to the occupants of the space so that if a 50% light level is not acceptable, they can go and activate the lights to 100%. But that actually saves even more money, or even more energy and money than vacancy sensing, because most occupants are going to leave that light level at 50% and go about their task. Hopefully they do have task lighting, as Jeff and Matt were talking about, if they need additional light than just the ambient light overhead. If you're going with a standard vacancy sensor where the lights do not turn on at all, most occupants, even if they're able to turn the lights on to 50%, are going to turn them on full just to be safe. So that's why you're actually saving more money with that other strategy. So there's three options within this spectrum, and it's important to really decide what's best for your tenants or your occupants. There's not necessarily a best option here. It depends on the space type, what's going on in that space, and what people are comfortable with. Occupancy sensing studies show between 20 and 60% saving, but that's really dependent on the space and how it's being utilized already. Right? Are people really good at turning the lights off after themselves? How often are the spaces being occupied and unoccupied? Are they just leaving to get coffee and coming right back, or are people going into meetings all the time? So it's really going to be dependent on each project. Let's go to the next slide. So moving on from occupancy and vacancy sensing, the next strategy is really just to have multi-level lighting or dimming available. Right? We mentioned that quite simply, either turning the lights off or dimming them are the only ways to save energy. If you only have switched lighting, your only option is to turn the lights off. Right? There's no other opportunity for energy saving. So making sure that some areas are able to dim can definitely offer you additional savings. There's also a lot of studies out there showing that if lights are able to be dimmed and occupants have personal control of their lighting, they will usually go to a lower light level. So that personal change, that manual control, can often save between 10 and 20% of your lighting usage as well. But one of the most important ones that we wanted to discuss today is going to be daylight harvesting. So, of course, bringing into the space has a lot of benefits beyond just energy saving, right? Including improved productivity and occupant health and well-being. So let's make sure that the controls that you guys are deploying in your spaces have the ability to adjust that electric lighting based on the amount of daylight harvest or daylight light that's coming into the space. Let's go to the next slide. So what is daylight harvesting? Daylight harvesting is really just a sensor. You guys can see an example there on the slide that is allowing the lights to be adjusted based on that daylight coming into the space. So those sensors are typically optimized over a table, a desk, whatever is in that particular space type. And you're setting, hopefully for the IES standards that Jeff and Matt referenced, that you want a certain light level on that work surface. What that sensor is going to do is strive to maintain that same light level on that work surface throughout the day. So as additional daylight comes into the space, if you have dimmable fixtures in that space, the lights overhead are going to slowly dim. More and more daylight comes in, those lights are going to dim even more. But at your work surface, your light level is maintained. So this is actually a great strategy where you're saving a lot of energy and therefore a lot of money, but you're also improving your productivity of your occupants because they have a consistent light level throughout the day that's not getting brighter or dimmer as they're trying to do their work. You can achieve daylight harvesting through switching, but it's something that you really want to think about whether you've got that switching or dimming. If you only have switched lights within a space, that sensor is only going to turn the lights off when there is enough daylight to illuminate the space entirely. The only problem is that it is a much more distracting event when the lights fully turn off. And we have experienced that in places that are consistently occupied, let's say an open office, it's often cause for the occupants to think that the sensor, the occupancy sensor, is not performing correctly. And so they get distracted, they stand up, they wave their arms around, nothing happens, they're all talking about it, they call maintenance, right? And it's really the daylight sensor that has turned those lights off and not the occupancy sensor. It's also just distracting because if, let's say, a cloud goes by and that light level from the daylight is no longer enough, those switched lights may come back on and then go back off. So code is moving towards having automatic daylight harvesting that does require dimming in an occupied space like an office or a classroom. But that's not to say that switched daylight harvesting couldn't benefit you in a space like a corridor, right, or somewhere, perhaps a lobby that is not consistently occupied. It's just something to think about. The fixtures that you're going to have responding best to daylight harvesting are usually 1.5 to 2 times the height of the window into the space. So if you have a 10-foot window, you can get 15, even 20 feet into the space and affect those electric lights without compromising the light levels on the work surface below. So daylight harvesting is a huge opportunity. There are, again, studies out there that show 25 to 60% savings for this strategy, but that's really, again, based on the space type. How much daylight are you truly getting in, right? Not just the window size and height, but also where is your building located? What's outside of your building? Are you being blocked by other tall buildings, or do you have direct daylight penetration? There's a lot of different options there to achieve that savings, but it can really be a very significant opportunity. Let's go to the next slide. In addition to daylight harvesting, the last strategy I wanted to mention is plug load control. This is a little bit separate from lighting, but it's also kind of integrated, right? And that your plug loads, such as a task light that's on your desk, we want to make sure that those aren't on when they're not needed. So in addition to the overhead lighting being turned off through an occupancy or a vacancy sensor, now we're looking at plug loads being turned off by that same occupancy or vacancy sensor. That is just starting to get into the codes in our area, and you might start seeing projects that have that integrated. But that's kind of the next frontier is those vampire loads, they call them, right, where there's a cell phone charger or some device that's pulling energy even when it's not in use, or something like a task light on your desk that needs to be turned off. An important thing to note when you're tying in something like plug load control is that you're going to tie that into, hopefully, the same occupancy or vacancy sensor overhead. Just keep in mind, in an area like, let's say, a private office, you want to make sure that that sensor is capable of doing vacancy sensing for your lighting, right, where it doesn't automatically turn your lights on. It forces you to make that decision. But most likely you want your plug loads to automatically turn on when you walk in, so those need to be occupancy. So just thinking about those types of sequence of operations, what's happening in the space, is really important to deploy these strategies correctly. Let's go to the last slide. So now that we've reviewed all those different strategies, they can really allow you to achieve significant energy savings from lighting controls. But it's really important to note that you can deploy these strategies in different ways. And I really like to think of two different types of systems. One would be a set it and forget it style system, where you're programming everything once and it just runs. Right? You know that you want your open office to operate in a certain way, that you want your private offices, your corridors, you know everything that you want to happen, and so that just happens automatically and saves you that energy that you're planning on. The other type of system would be more of a proactive system, where you can actually monitor the usage of the building and continue to optimize it and achieve more and more energy savings. So there's a lot of systems today that can offer the features that you can see here on the slide beyond energy savings. Right, when we talk about occupancy sensors, not only do we want to use those to save the energy of the electric lights in the room, but perhaps it would be good for you to know for space planning purposes, how often are conference rooms actually being used? How many people are actually in their private offices and for how long? Do they really need those private offices, or could you go to something like hoteling? Looking at managing your space remotely, right? If you're having an issue on site, do you need to have someone physically run up to the 7th floor to help them understand why the lights aren't doing what they expect? Or can they make a phone call and someone can actually remotely control those lights from somewhere else, from a computer or some other device? And then again, that reporting side of things, to know exactly how much energy you're saving and to potentially be able to compare. Why is the 5th floor saving more energy than the 6th floor? Well, it's because someone's pulling the shades down at 7 or 8 o'clock in the morning every morning, and they're never going back up. They're never allowing that daylight penetration to take advantage of the daylight harvesting. Just allows you to be more proactive in interacting with your control system and hopefully getting additional energy savings from that. So I'm sorry I went a little fast there, but I wanted to make sure that we left plenty of time for questions. So we can, I believe, open it up for questions now, and Anka is going to moderate.
Great. Thank you so much, Amanda and Jeff and Matt, for some great info on optimizing lighting strategies. We have some questions from the audience, and I think some may have already been addressed as kind of the presentations went on, but I'm going to go through them anyway in case you wanted to add anything. I'll just paraphrase it. And this is for Jeff and Matt, but I think also for Amanda. At the very beginning, Jeff, you had talked about risk budgets, tech, and performance, but you didn't mention regulations such as the energy code. Can you address that a little bit? Or I know you, and Amanda, I know you had mentioned it a little bit later as well. So is there anything else that you wanted to add?
Yeah, this is Jeff. Yeah, I'll just quickly mention something, and if either Matt or Amanda want to jump in as well. So from an energy code standpoint, obviously ASHRAE 90.1 is the prime driver from an energy code standpoint. The rate of adoption of that version as it continually updates on a regular basis is something that varies by state. But so some states may have adopted a more current version of ASHRAE with more stringent energy requirements from a lighting standpoint than others, or also control requirements like Amanda mentioned. There's significant lighting control mandates that are coming through energy codes as well. I think the one connection into our presentation in terms of establishing how much light is appropriate for a space is to realize that those codes established by ASHRAE in terms of energy allowances for lighting are built and developed on the IES recommended levels. And those are requirements by building type. So again, if you stray from those and are providing more light than necessary, you simply won't be able to meet the energy code in those kind of conditions. Amanda, I'm sure there's probably quite a bit you could talk about in terms of
Yeah, definitely. From a controls perspective, code has been driving significant adoption of different lighting control strategies depending, again, on the state. So it's pretty commonly known that California is the most stringent in their energy codes, but Maryland is actually second to California. They have adopted the most recent ASHRAE, which is the 2013 version, and definitely have the most strict projects. But DC is not far behind that. They have not adopted that version of ASHRAE, but DC does have its own green code that's pretty strict as well. So really in this area, we're a lot farther ahead than other areas of the country in terms of what we're kind of forced to do, including vacancy fencing, daylight harvesting. A lot of what I mentioned is required in new buildings in our area today.
Great, thank you. Next question. There are a lot of lights on full brightness besides large floor-to-ceiling windows. Can you comment on daylighting controls? And I think that was addressed. So is there anything else that you wanted to add?
Yeah, I mean, hopefully that was addressed in the daylighting slide that I had there. That's absolutely one of the biggest opportunities, right? And to deploy a sensor to be able to adjust those lights to take advantage of that daylight. Absolutely. Great.
Next question, I think, again, this was also mainly addressed, but just going through these. Given that CFL and fluorescent fixtures are less efficient and more toxic, do you ever design new projects with anything but LEDs? If so, then why? Is it cost?
Yeah, this is Matt. I think I can respond to that one. I think, as we said, there are some circumstances where I think fluorescent, predominantly due to its efficiencies and cost, are a good alternative. But I would say that predominantly what we're designing with new construction is LED across the board. There are few instances, shy of really trying to drive costs down in strategic locations where we stray away from it.
Great, thank you. And last question, does LED luminaire mean a new fixture change out versus an LED retrofit to an existing fixture?
Right, this is Matt again. I think I can do that one. Yeah, that's the primary difference between what we were calling kind of the base LED, which is, that means you are putting in a brand new fixture that was designed around an LED board. It was intended to have an LED light source in it and an LED driver, and all components of the light fixture were designed around that purpose. The retrofit that we were looking at is assuming that you have an existing light fixture, be it linear fluorescent, or there's other systems that can be implemented if you're looking at even halogen downlights or other types of things, where you can take an LED package and insert it into a fixture that was designed around a different light source.
Great. Thank you so much. So those were the questions. Thanks again, Jeff, Matt, and Amanda. We really appreciate your taking the time to share all this information with the participants. And thank you, everyone, for attending. And as I mentioned at the very beginning, we will be posting this to the Smart DC Challenge YouTube website. And if you want to learn more about the Smart DC Challenge, feel free to go to smartdcchallenge.com. Thanks so much, everyone, and have a wonderful day.
Thank you. Thanks.
Thanks.